Welcome back, class 9th. Today we are going to start with the next chapter, chapter number 13, Surface Areas and Volumes from your NCERT textbook. Your chapter is spread over a total of 8 exercises, out of which the first 4 exercises are based on surface area of solid shapes and the next 4 are based on the volume of solid shapes. The very first exercise is based on the surface area of a cuboid and a cube. Before we proceed with the questions of the exercise, let us recall and revise how the formulae have been established to find out the surface area of a cuboid and a cube. So let us start with cuboid. I have drawn a sketch for a cuboid here. To find out the surface area of a cuboid, the first thing that I want to do is I want to represent its dimensions. So taking its 3 coterminous edges as L, B and H. By coterminous edges, we mean 3 edges which emerge from a common vertex. So if you take any of the vertices for this cuboid, I've taken this one, the one at the bottom. There are 3 line segments emerging from it. One is a horizontal one, a slanting one and a vertical one. I have marked them as L, B and H. The horizontal one represents L, the length of the cuboid. The slanting one represents B, the breadth of the cuboid, and the vertical one represents the height of the cuboid. That means all the horizontal line segments represent length of cuboid, all slanting line segments represent breadth of the cuboid, and all the vertical line segments represent the height of the cuboid. In order to find out the surface area of a cuboid, I want to find out the area of all of its surfaces. Since a cuboid is bound by rectangles, so to find out the surface area for a cuboid, I want to find out the area of all these rectangles. So there are a total of 6 faces for a cuboid. So I want to find out the area of these 6 rectangles. The faces are rectangular in shape and the area for a rectangle is given by product of its dimensions. We usually represent the dimensions as L and B, which I'm not taking here. I'm just writing this so that you can remember whatever the dimensions are of the rectangle, we multiply them in order to find out the area. So for a cuboid, let's start calculating the area of its 6 faces. Let's start with the top and the bottom. If you look at the top and the base, we know that these are identical rectangles. Identify its dimensions. So the area of top equals to area of base, and see since both of these are rectangles, the area will be given by the product of the dimensions. Observing the rectangle at the base, the dimensions are L and B, so the area will be given by the product of L and B, which is LB. Now let us see what are the dimensions for the side faces. So if you look at the rectangles on the side, the dimensions are B and H. The area for the side faces will be given by the product of B and H. So area of each side face is equal to the product of B and H, the sides of this rectangle. Then we have area of front and the back face. So area of the front will be equal to area of the back face. Observing the dimensions, the area of the front and the back rectangles. This is the rectangle on the front. The dimensions for this are L and H. Same will be for the rectangle at the back. So the area for this, the rectangle shaded in red, is L multiplied by H. So 2 faces have an area LB, 2 faces have an area BH, and 2 faces are there which have area LH each. So the total surface area for the cuboid, we will be using the acronym TSA. It is given by the total of all of these areas. So there are 2 faces with area LB, 2 faces with area BH, and 2 faces with area LH. 2 can be taken common, LB plus BH plus HL. You can write LH as well. Now this gives us the area for all of these surfaces. Now consider an example. If you have to paint or find the area only for the walls of your room, you don't need to find out the area of the top and the base. So to find out the area of the four walls, we have a particular term and we refer to it as the lateral surface area. The lateral surface area means the area of the sides, the side faces, not the top and the bottom. The top and bottom are excluded. So the lateral surface area, acronym used is LSA, of cuboid is given by the area of the side faces. We will not be taking the area of top and base. We will be taking the area of the side faces, two side faces, and the front and the back. So this will be given by 2 times LH, the area for front and back, plus 2 times the area of the side faces. So from here I can take 2 and H common. So 2 times L plus B, H common. This actually is the perimeter of the base. So this 2 into L plus B into H is perimeter of base multiplied with height of the cuboid. This is another formula which can be used to find out the lateral surface area of cuboid. Let's move to the second shape, which is a cube. For a cube, the dimensions are equal. A cube is bound by squares, not by rectangles. In case of a cuboid, since it's bound by rectangles, the dimensions are taken as L, P and H, assuming they are not equal. The two values are not equal at the same time. For a cube, it's bound by squares, so that means all the dimensions are equal. Since length, breadth and height are equal, let's represent them by a same variable, means the 3 coterminous edges, horizontal, vertical and the slanting one, will be equal. Let's represent them by 8, means length, breadth, height are all equal and they have all been represented by the variable A. You could take any other variable, you can take X or you can take L. Now since a cube is bound by squares on all sides, to find out the surface area of a cube, we want to find out the area of each of its square faces. Now what we know is area of a square is given by square of its side, side squared. So in case of cube, area of one face will be given by the side square. Now the side has been represented by A. So if the area of the front face is to be calculated, it will be A square. And if we have to find out the total surface area, we need the area of all 6 faces. So if the area of one face is A square, the area of 6 faces will be 6 times A square. So this gives the total surface area of cube. If we have to find out the lateral surface area of cube, means we don't want to include the top and the base, then 2 faces will be excluded. Out of the 6 faces, we will be left with 4 side faces. So the lateral surface area of cube will be given by 4 times A square. So this is what we have, and these are the formulae that I will be using to do exercise 13.1. Along with this, there is one more relation that we would like to learn here. If we have to find out the total of all the edges, either for a cuboid or for a cube, the total length of all edges. For a cuboid, observing from the figure here, how many dimensions are there? There are a total of 12 edges, out of which 4 are the lengths, the horizontal 4 line segments, they are the lengths. 4 are the breadths, 4 slanting line segments, they represent the breadths. 4 vertical line segments, these represent the height. So there are 12 edges. So the length of all edges will be given by 4 times the length, 4 times the breadth and 4 times the height, which can be written this way. For a cube, since all 12 edges are equal, each edge is represented by A and all the 12 edges are equal, 4 horizontal ones, 4 vertical ones and the 4 slanting ones, all 12 are equal. So the cube, for a cube, the length of all edges will be given by 12 times A. Using these formulae, we will be trying to do exercise 13.1, and depending on the question, you will decide whether you're going to use the formula for the total surface area or for lateral surface area, or you just need to make a little change to either of these. For example, if you have to find out the area for a box which is open on the top, that means only one face needs to be excluded. So you will find out the area by using this, but you will subtract one of the faces. So total surface area minus the area of the top face, LB. Or you could do it the other way. What you can do is you can use the lateral surface area. Lateral surface area means the area of the four sides, plus additionally you need to add the area of the base. So lateral surface area plus area of the base, this is one way to find out the area of that box which is open on the top, or you can use the total surface area and subtract the area of top from this formula. So decide how you want to proceed.